Hello class, today we are looking at parallel lines and proofs. We've already done a few proofs before in class, so this is nothing new. The proofs we are doing are what we call two-column proofs. Your essential question, how do I use properties of parallel lines to write proofs? Your learning intention, I'm learning to use properties of parallel lines cut by a transversal in proofs. So you have a warm-up that is actually a proof. So if 2x plus 5 equals 21, then x equals 8. For the proof, you have to give the reasons why we can do things. So what do we start with? We start with the given. So this is our given information. What have we done here? We have subtracted. So this is subtraction. Property of equality, POE. How do we go from here to here? We have simplified. Okay, now on this one, we do what? We divide by 2, so that is our division. Property of equality. Okay, how do we end our proofs 100% of the time? With what we want to show. So, x is equal to 8. Now, we've simplified. I want to tell my reader that we are done, so I'm going to use the infinity sign because that's the one I like the best. You can use QED. There's a third one. I'll have to look it up because I always forget it. Okay, so now looking at the next one. You're given two intersecting lines. We want to show that vertical angles are congruent. So, what do we start with? Well, we're given two intersecting lines. When we look over here, we've got all these different angles. So we're going to start with the given, which is two intersecting lines forming angle 1, angle 2, angle 3, and angle 4. Okay, if I'm looking for linear pair. If I look in angle and statement 3, it shows me which ones I need to use. Definition of a linear pair, two angles that form a line and they are supplementary, so their measures add up to 180. So the measure of angle 2 plus the measure of angle 4 equals 180 degrees. The measure of angle 4 plus the measure of angle 1 equals 180 degrees. That's your definition of linear pair. So how do I go from this to this? What is it called when we replace a quantity with something it is equal to? Begins with an S. If I'm not at school for the day, what do you have in my place? A substitute. So this is substitution. And you could also use a transitive. Transitive means if this is equal to this and this is equal to this, then they've got to be equal to each other. Okay, I'm going to use subtraction. What can I remove here? What's on the same side of the, what's on opposite sides of it, the equal sign? The measure of angle 4. So if I remove the measure of angle 4, I get that the measure of angle 2 is equal to the measure of angle 1. I've just subtracted this measure. Any angle measure is a number, which is why we can subtract it. Okay, now, we always end with what? Vertical angles are congruent, so I will say that angle 2 is congruent to angle 1 by definition, and I am done. So I'm going to do my little infinity again, but I've only proven it for one pair. I've only proven it for 2 and 1. I need to let the reader know I could do the exact same thing, and it would be true for angles 4 and angle 3. So likewise, angle 3 will be congruent to angle 4. Okay, from now on we can use the statement that vertical angles are congruent because we've proven it. After you prove something, you can use it in all your following proofs. But everything has to either be proven first or be a postulate. Okay, parallel lines cut by a transversal. You've got figure A and you've got figure B. Both of those are parallel lines cut by a transversal. So, there are several different types of angles formed when parallel lines are cut by a transversal. The first we're going to look at is the corresponding angles. When two parallel lines are intersected by a third one, which is the transversal, the angles that occupy the same relative position at each intersection are known to be corresponding angles to each other. Okay, so we're going to look at the corresponding angles in figure B. If you notice, each of the lines has 4 angles. So there'll be 4 angles over here that correspond to these. If I am looking at angle 1, angle 1 corresponds to what? If you're here, it's to the bottom and up above. If you're here, to the bottom and up above. So that would be angle 5. Those are corresponding, and they're going to be congruent. Okay, what about angle 2? It's to the top and to the left. To the top and to the left is angle 6. Okay, let's look at the other 2 that are on the bottom. So, if I'm looking at angle 3, angle 3 is to the right and at the top. So to the right and at the top is angle 7. Okay, and the last pair has to be congruent also. Angle 4 and angle 8. Okay, parallel lines cut by a transversal, then the pairs of corresponding angles formed are what? They are congruent to each other. This is your postulate. Postulate means that we do not have to prove it. We accept it as a statement of fact without ever proving. Besides corresponding angles, what other angles in figure B will be congruent? Okay, if I'm looking at angle A, or angle 1, if I'm looking at angle 1, I know it's congruent to 5 because they're corresponding. What other angle is it congruent to that we've already proved will always be congruent? Angle 1 and angle 3. So angle 1 and angle 3, what kind of angles are they? Because they are vertical. So let's look and see how this all plays out. I know that angle 1 is congruent to angle 3 because they're vertical. Angle 1 is congruent to angle 5 because they're corresponding. Angle 5 is congruent to angle 7 because once again they are vertical. So I know that angle 1 will be congruent to angle 3, which will be congruent to angle 5, which will be congruent to angle 7. So that's one set. Angle 1 is congruent to angle 3, which is congruent to angle 5, which is congruent to angle 7. What about the rest of them? If I'm looking at 2, 2 is congruent to 4 because they are vertical. 2 is congruent to 6 because they are corresponding. 6 is congruent to 8 because they are vertical. So I know that angle 2 is congruent to angle 4, which is congruent to angle 6, which is congruent to angle 7. So, the question is, what do we know about all the angle pairs when parallel lines are cut by a transversal? There's only, if you pick any two angles, there's only two things that can happen. First, they could be congruent. Or second, if they're not congruent, then they have to be supplementary. Now, I can't say linear pair because they might not be on the same line. But any two angles you pick will either be congruent or they will be supplementary. Nothing else can happen. I know I'm successful when I can identify the different angle pairs when parallel lines are cut by a transversal and identify their relationship. By identifying their relationship, are they congruent or are they supplementary? Parallel lines and transversals and vertical angles. We proved that vertical angles are congruent.